In this lecture, I'm going to describe the biochemistry of collagen, one of the most important proteins in our body for helping to hold all the components together. The word collagen originally came from the Greek, the word kala meaning glue, and the word gen producing. Collagen was originally made by boiling the hooves of ungulate animals to make glues to stick other things together. Gelatin, of course, is a source of collagen that has been irreversibly hydrolyzed to produce the characteristics of gelatin that we know. There are many medical uses for collagen, and one of the more common uses of collagen today are used in ointments or beauty treatments to help keep the skin looking young and youthful. Collagen is the most abundant protein in our body. About 20 to 30% of all the body protein that we have is made up of collagen. The synthesis of collagen changes as we age. It decreases in terms of quantity, and it also changes in terms of its flexibility. One of the reasons that we get stiff and cranky as we get older is because our collagen is less flexible. There are 29 different types of collagen found in the human body. Over 90% of the collagen in the human body, however, is just type 1. So there's a very big difference in the amounts of the different collagens that are actually made. The most common types that we have in our body are types 1, 2, 3, 4, and 5, and that's pretty much in terms of decreasing order of each of those. The type 1 collagen fibrils are stronger by weight than steel, which really says a lot about the importance of the strength of this important protein. The basement membrane of the extracellular matrix is composed of collagen, and it is this basement membrane that actually helps to hold all the different components of our body together. But one of the very important characteristics of collagen is that it surrounds the blood vessels. And when blood vessels are damaged, the collagen gets exposed. And it's the exposure of the collagen that helps to signal to the clotting system that there's been damage and it's time to start the clotting process. Now, there are 5 different types that are primarily found in the body, as I said, among the different 29. Collagen type 1 is found in skin, tendon, vascular ligature, in organs, and in bone. Collagen type 2 is comprised primarily of cartilage. Collagen type 3 is found in the reticular fibers, and these are the fibers that help to give the organs the characteristic shapes and structure that they have. Collagen type 4 is found in the basal lamina and the epithelium-secreted layer of the basement membrane, as I mentioned previously. Finally, collagen type 5 is found on cell surfaces, primarily around the hair and in the placenta. Now, this shows the basement membrane that I was describing earlier. If we look at the top row, we see a line of epithelial cells. We could think of this as the outer portion of our body. Beneath that, we have the basement membrane, which I'll describe in a second, and beneath that, we have individual blood vessels, which themselves are lined by a little red layer of epithelial cells. Those epithelial cells are a signal that everything is okay and intact. If damage happens to a blood vessel, that epithelial layer is broken and the basement membrane is exposed, letting the blood clotting system be exposed to the collagen. That is a signal that damage has occurred and the clotting process must begin. Now, collagen comes in a variety of states. The state of the collagen actually depends upon the amount of mineralization that a given type of collagen has experienced. So, for example, bones and tendons and cartilage tend to be harder and have had more extensive mineralization, whereas fibrillar and non-fibrillar types may be more flexible and not quite as hard. The most abundant fibrous tissue that we have are in the ligaments, the tendons, and in the skin. Now, collagen is a fibrous protein, and fibrous proteins have long repeating helices that go on for quite a long distance. The collagen repeating unit is a triple helix, and that's a fairly unusual protein in our body, and it's even more unusual in the way the individual units are made, as I will describe in a second. Now, each polypeptide chain that's found in the triple helix of collagen contains about 1,400 amino acids, so it's a fairly long protein. The type 1 collagen contains 2 identical alpha 1 units and 1 alpha 2 chain, and these are arranged in a right-handed helix. Now, that's kind of unusual because each chain of the alpha 1 and alpha 2 is itself aligned in a left-handed nature. Now, when I talk about the left-handed and right-handed orientations of helices, that's a little hard to imagine, so let me just take a second to describe what that's like. A left-handed helix can be described as left-handed if you point it away from you, and in pointing it away, the helix coils away from you in a counterclockwise direction. A right-handed helix will coil away from you in a clockwise direction as the helix moves away from you. So the individual chains are left-handed, but the left-handed chains are wound together in a right-handed form, a very unusual structure. Now the strands are combined together to make fibers, and these fibers, as I've noted, have considerable strength. The strength arises from chemical bonds that occur between the individual helices, as we shall see.